Hmm. Okay, so we do the formula for the standard deviation, yes. So we know that the variance s squared is going to equal x minus x barred, the sum over n minus 1. And if you take the square root of both sides, that's going to be the standard deviation s. So we're kind of going for that. The entire problem always is about this one symbol. There should have been a squared there, and there's a squared, yeah. And it's all one number, it's okay. Everybody in the beginning gets a little bit stressed out about that, depending if we don't have a background in math, but it's just the sum of a column, that thing right there. So in reality, one var stat, we would never ever do a sample standard deviation by hand. Every computing system, TI-84, graphing calculators, Excel, every computing system, of course, just spits out the standard deviation, but we're still required to know the formula by hand. So here we do that. Okay, so we have L1, which is just our x's. We have to have them in a column. So obviously we just write all those. Yeah. So what we do is if I kind of write over here on the side, a side note, it's just because I'm trying to save room, but we have to do one var stat L1 instantaneously. Yeah, one var stat L1, and we have to get the X barred. So we do one var stat L1, we're looking for the X barred, which is the sample mean. Yeah, 0.90909. So we get that there. Yeah, so we don't actually type in L2 equals or anything. We scroll up into L2, remember, scroll up in there and we can type an equation in there. We have to type in L1 minus the mean. Yeah, we have to type in L1 minus this number. And what is that symbol going to be? That's going to be X minus X barred is what that's going to be. So it doesn't matter if stuff comes out negative, it has very little to do with it because we're going to end up squaring this stuff, but we get that 0.91, we get 21.091, we get negative 10.91, blah, 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 all the way down. Yeah. So then in L3, we want to type in L2 squared, yeah. And then we get things like, what is that going to be? It's going to be x minus x barred quantity squared. It's going to be the last symbol squared. So that's basically it. We sum the L3 and then we get that. But I'm getting numbers like 571.64, 444.83. We get all of that all the way down there. So then if we do one var stat, yeah, one var stat L3, we get the sum of this symbol. We get this symbol, we get the sum of all x minus x barred, 180 squared. Yeah, if we sum L3. So what I am getting there, and we're going to have to kind of erase everything here. Some people, this is L1, L2, L3. This is kind of a very typical way of illustrating this. Yeah, some people will we have to have our L1. Obviously, we have to have that. And then some people will kind of in L2 do this formula all in one fell swoop. That's fine. We just have to understand the basic thing that you can scroll up into the thing and do a formula. And then that's my little arrow for scrolling up into L1, L2, L3. Yeah. So we do one var stat L3. And we get, what do we have? We have 8098.9. So it's never necessary to take this stuff out to decimal after decimal after decimal and all that. But if we want to be clear about this, then we have to have that. Yeah. So the whole point of the entire problem is the sum of all x minus x barred squared, and that's going to be approximately 8 0.9098.90909, blah, 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 that goes on, yeah. So then we just do S, and it's going to be the sum of all x minus x barred squared over n minus 1, the square root. And then we do that, that's 8098.91, take the decimal out as far as we want. The n is 11, so it's divided by 10, n minus 1, we do that. And we should get the same thing as if we just one var stat, we have to compare it, make sure we don't make a mistake. We have to compare it to what we would actually do, one var stat L1, which will give us the mean and the sample standard deviation. So if I do the formula, I get, say doing this here, takes just a minute to do the formula. If I do the formula, I get the standard deviation is 28, approximately 28.5. And if we do one var stat L1, we get 28.5. So those are great. Those are going to be the things there. That's basically the problem. We don't have to go on and on and on and on. And if you square this thing, just remember square S. There's no special symbol for variance. It's just S squared. Write it on the board, but by this time we've already written it a dozen times. 28.5 is S, the variance is S squared, which is S squared, and then C is just something stupid. Okay, perfect. Okay, so if we read this thing, it's just two problems. We're going to have like an A and a B or an A, B, C, D or something, yeah. But we have two sample sets, systolic and dystolic. We treat them as two different samples, and they want us to do the coefficient of variation for each one. So this is fine. We don't need like a special video for coefficient of variation. The CV, coefficient of variation, is just going to be a S divided by X barred. So we would never do the crazy standard deviation formula. We would never do it. We always just do one var stat for both of those. Obviously, one in L1, one in L2. Do the one var stat for each one of those right there. And then you get the S, you get the X barred, you just divide them, and then we have the coefficient of variation. Don't even really have to know exactly what it means there. Okay, so the coefficient of variation, of course, has a physical meaning. There's many things like this where it's very simple, but I don't mind admitting that it's pretty hard to understand. We have the coefficient of variation, which is literally the sample standard deviation divided by the sample mean. It's considered a measure of dispersion, and as if that, you know, a measure of dispersion, as if that really tells us what it is. But specifically, uh, so all we can really say about the coefficient of variation is the higher the number, yeah, the greater the dispersion around the mean. But it's kind of like, obviously a greater standard deviation would mean a greater CV, but it's not only that. So it's kind of an ambiguous number there. So I find it a little bit difficult to define, but that doesn't really matter. Okay, so we kind of go ahead and do this here. So we're not really worried about this. What exactly are we doing? We don't have to show all the work. We're just doing list 1 and list 2. With that, we would do list 1 is systolic 116, 129, 157. Yeah, that's 80. That's 76. That's 74 all the way down. Yeah. Okay, so basically we do one var stat. Yeah, L1. Yeah. So we do one var stat L1. And then this is going to be, we can just kind of label it here for the systolic, the CV, which is the S over the X barred, is going to be what? It's going to be approximately 17.9307. Remember, the decimal is not so important, but when in doubt, just take the decimal out very far, 127.2. So we basically calculate that now, but it's kind of on the readout. So just trying to kind of do all of it at once. I'm sure in just a minute they'll have us do the next one. So we do that one where the CV, that's going to be one var stat L2, correct? Because we typed all that data in L2. Okay, so we do those. And then we round somewhere they want us to round. We have to be careful, it's percentage. So quite oftentimes as a percentage, like anything else, it is a fraction or decimal, that's what it is. So if we want a percentage, technically, even if we don't write it, we're multiplying by 100%. It's not usually too important that we write that, but mathematically it is correct. Okay, so I get approximately round where? Rounded to, yeah, rounded to 1. So I get 14.1, and then I get what down here? Okay, so that's basically work right there. I always go kind of a little overkill in my video, very easy to calculate. We don't need a 10-minute video for it, but we just kind of go through it very thoroughly as we do that there. So let's erase that. So I was kind of struggling, honestly, to kind of give the coefficient of variation a little bit of meaning. We're supposed to kind of know that. Explain it in exact definition is hard, but the last one kind of gives uh, a little bit of a meaning to it. So basically, if we do that for both, we can kind of tell, whether or not they're strongly different from each other. So with this one, they're about the same because they're within 5% of each other. So we do have that. So we are doing the empirical rule, which I would prefer to save to the next video. We're covering about 2, 3 concepts in each video, just kind of going with the flow. So the next video will be empirical rule.